Wow, thank you so much for that introduction. I am Brooke. I go by Going for Brooke online because my last name is kind of tough to pronounce and even harder to spell. I stream on Twitch. I have recent experience in like aerospace industry, AI stuff, all kinds of just like, the memeiest San Francisco things that you can do. And for the past 6 or 7 years, I've been working on this really weird language, which Rust, something you might have heard of. And for a really strange application where I'm building a client-side application to fight human trafficking, which is super strange and super cool, but I can do it with one binary to fight them all. In fact, to find out more about me during the talk, these are some of my handles. I post across all platforms. Hit me up on DMs or at me if you want to hear anything more. What we do at Trafficking Free Tomorrow, we are a 501c3 nonprofit, which in US terms means that the federal government likes the stuff we do so much that they think that we're tax exempt, which is pretty cool. We try to make tools that make evidence portable, provable, and private. We want to kind of challenge the current paradigm of forensic tooling and e-discovery tooling, which is a very large industry which tries to charge government as much as possible and really breaks down opportunities for interagency cooperation and really kind of edges out the international community and NGOs to come together and fight this global problem. We kind of make software that doesn't need a server farm. We're making client-side applications, and we're trying to make something that you can write once and run anywhere, which is something that Rust really wanted to make good on. We'll kind of go through in this talk some of the things that happened along the way. Some key takeaways are probably going to be some deployment stories, since we're pushing to macOS, Windows, and Linux, what that would look like for you if you went down that road, some of the things that we ran into, and what's happened over the past 4 or 5 years as I've seen Rust grow and where it's going in the future. So the United Nations Office on Drugs and Crime notes that most victims of trafficking are exploited in their country. I'm a survivor of this. I've had personal experience with this, and it happens locally. It's happening right in front of you all the time, and you don't really realize that it's there until it's looking you in the face. But if we're actually going to lock down on these things, I think we need to get to the root of the problem. We need to break up these networks. And the reality of it is that they're funded and they are managed internationally. These are networks and criminals that don't care about borders. They don't care about laws. They don't care about law enforcement. And if anything, they know that the more they cross borders and the more different platforms, the more technology that they use, the more noise it makes, the more it overwhelms law enforcement, the more that it overwhelms authorities and makes it hard to prove and makes the product, humans, actually a lot more valuable. So if we can find ways to break that up, then we can actually find ways to break up these networks and get some headway on the problem. A lot of this comes down to getting evidence down the last mile with people as products and thinking about this as an international supply chain of exploitation. What can we do to trace some of these people back to the original folks who are trafficking them? What can we do to kind of bring some accountability to some of the countries that let this happen? What can we do to find main arteries and vestiges where we can keep this from becoming more of an issue? We live in a world now where we have a lot of political instability around the world. That makes more displaced populations, that makes borders more porous, makes more issues. And at these borders, at these places, we'll see later in the talk, a lot of times we don't have the best hardware, we don't have the best software, we don't have the ability of an internet or even a server-side application, which is where development has gone over the past 20 years or so. In the same way, UN Human Rights Council talks about how traffickers use more communication technologies. And their solution for this is that they need to work with technology companies, that places like Facebook and Instagram, the places where traffickers find and groom victims, where they exploit them, need to be cooperative with local authorities and NGOs and other things like that. And they need to all come together, and it's kind of like kumbaya future where we can just share information and everything works out somehow. The reality of that is that it comes down to compliance for them. They're trying to do the minimum that they can to be compliant with whatever laws or customs of the local country that they can work in so they can keep selling their stuff and moving on. So what we try to do is we try to build the gap between those things and make that evidence easier to move and to understand. A lot of this stuff is automated. A lot of it is things that isn't really released, normally, search warrant returns, things like that. And a lot of it also involves really, I don't want to say like boring, but very simple things like chain of custody, which will often fall apart in court or in human rights councils. and being able to verify that a piece of digital evidence started somewhere, moved to somewhere else, and went to the next person. Making that whole chain, making a whole provable story there can be very difficult without the correct tools. And a lot of times these companies will be like, well, we'll just give them like a basic format. We'll give it to them. At one point, it was in PDFs that were too big to be opened in Adobe, and another point, it was in giant HTMLs. And they said, well, they can just use whatever language they want to parse their data. But a lot of times, that makes a lot of big assumptions about the skill sets that they have on hand. It makes a lot of assumptions about even having computers you can write any kind of modern scripting languages on in the first place. So a lot of times, I describe this as putting things into Excel and putting GUIs on Unix tools. We don't actually have Linux tools built into this, but that's a way to think about this. So if we're talking about this, a lot of times, like I'll even look at it sometime, I'm like, wow, this is literally like grep and a cat and maybe dumping to a text file and it would be done. But that's the paradigm that we're trying to get away from right now, where in governments, a lot of times you have these subject matter experts who will be digital forensics examiners, they'll be professional investigators who know the area, know the space, and they're kind of tasked with dealing with all the digital evidence needs of their organization. And that works up to a point until you get modern data needs and modern data applications which are making more and more data, and now they're just kind of overwhelmed. They're swamped all the time. So part of our work here is also trying to democratize some of the work that SMEs use. For the application we'll be talking today, Folsum, like I said, we're just putting things into Excel, putting things into spreadsheets. This is not something you need an SME to do. And there's kind of meat space multiprocessing, I call it, whenever you can break up these things with an email chain to 10 or 15 underlings in these highly hierarchical organizations, have them all go through and summarize, make 10 spreadsheets, send it back to the parent node and the person, and they can just copy paste and put those together. You just did 10 times the amount of work without needing to have 10 more SMEs to do that work. It's really important to us to prioritize mission over profit. Nothing that we create at Trafficking Free Tomorrow is really novel. None of it's really new. None of it's even like very cool or incredibly performant. But it installs anywhere. It doesn't have any dependencies. It doesn't have any special requirements. It's very easy. You can put it on Windows NT if you so need. And as a feature, it doesn't have any built-in like networking or things like that. And it has no analytics, no telemetry, which is really great for them because they're very scared about any kind of security. Security for a client usually means something that's air-gapped. They'll have an air-gapped, say, laptop with a, they don't go over some like general client specs, but maybe 2 or 3 gigahertz and 4 gigs of RAM. Excuse me. And they say, well, it's not connected to the internet, so it's not going to cause any problems. In this way, I can say, well, mine doesn't have any internet connectivity in the first place, so you can be okay putting it on devices that are connected to the internet, and that's like a big feature, or like an unfeature, I like to call it. Right now, there's this dearth of tools. This is kind of what we call like the gap, and this is how we're trying to fix it. That's right. As part of the gap, here in the EU especially, we have a lot of privacy laws, GDPR to start off with, but also very specific country-specific laws. And because government likes to process everything on their own servers, there's an issue where private industry will just kind of eschew these customers altogether because, I don't know, by a show of hands, who here is working on a desktop application that you like ship to a client? 1, 2, maybe 3. And who's working on a server-side application where you work on it through a browser? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. yeah, there's like a lot of people doing that now. So it's this kind of like lost art that a lot of people have almost like forgotten to do in some ways, or that they haven't written down very much online. So it's a bit of a struggle to put these things together and try to make something that can meet these. Because if you keep it on a local machine, if you keep it in one place, then you get data sovereignty automatically. There is no issue with sending off a bunch of data to a private company, or especially an American company, and get these very gregarious salesmen who come in and say, oh, just give us all of your data, just send it all over to us, we'll make it all better for you. You don't need spreadsheets, you don't need any of that old stuff, you don't need to install anything. But whenever you want your data back, then they'll give you a quote for how much it's going to cost to download that data back out of their system too. So it's a double-edged sword. And governments have rightfully become very skeptical of those kinds of things. But if it stays on your machine, you own it. There's no subscription service. There's no updates. There's no calling home. That's very attractive. On the other hand, TFT takes a big hit there because metrics are how we raise money. Whenever we go somewhere, especially in San Francisco, people want to see what is the ROI on this for every dollar that I give you. Say in the effective altruism community, how much is that dollar getting? How much good, how much cause is that changing in the world? How much benefit is that? And I really wish that I could put like a gigabyte per dollar of like process information, or how many hundreds or thousands of hours we save of civil servants in work weeks. They can move on and do something else with their time than, say, manually hashing files in this case. But we don't get that information. So if you ever meet someone who's using this and likes it, let me know. Part of this comes down to shipping and handling. With cloud storage, we don't really have digital evidence standards. There are a number of companies who say, well, we don't need a digital evidence standard. We'll bring it all together on the cloud. Like whenever I was in distributed engineering, I had a big Kubernetes cluster. I could always do self-provisioned or cloud-based storage. I had read-only copies. I had all these great like sharded databases, everything that I could do to cram all the data into one place and then serve it out to multiple other people. But since everyone is using client-side applications, everyone wants to keep the data on their own machines, you need to have a strong standard for being able to share evidence, and that doesn't really exist right now. Now, well, TFT doesn't want to propose a new exchange standard for sharing evidence in these cases. It would be kind of nice if we could just use the ones we already have, like CSVs, things you can already put into a spreadsheet. So what about server side? Like I mentioned, it's not going to work, but we have a thin client. Like I said, it's 2 to 4 cores, about 2 gigahertz, real sweet. It's got 4 gigs of RAM. Maybe we have eMMC flash, which is kind of nice. These things used to be spinning platters, which really slows things down. And it's especially tough to get a call from a customer who's like, it's being slow. And they don't know, what's going on with that, or using on this server, that server. Who knows what's happening here? With Rust, we get to keep it all in memory, and we don't have to deal with a lot of these problems. It's kind of fast by default. It might load a little bit in the beginning, but that's okay. Let me see. So we come down to Folsum, which is folder summarizer. What it does, we go through and we hash things, basically. We have a directory full of files. We say which files are in the directory, and we do a few different hash things on them, MD5, SHA-1, SHA-256, and that becomes the signature of the fingerprint. And every time it passes to a new person, say in the US, you need to have a chain of custody that says it went from this person to this person, wherever that happened. The hash didn't change, the hash didn't change. And the same way, anytime you send something to someone, before you zip it up, before you move it, like once it's compressed or uncompressed, that becomes very worrisome from a legal standpoint. So this lets you kind of prove things and act as a container. But the container isn't proprietary. It isn't like a, .proprietary format. It isn't some new way where we compress something as a zip and then we encrypt it a little bit. We put our special logo on there and, okay, now you can download your thing from the server at a price and you can put it into a compressed file that's 2 or 3 terabytes, send it over to another thing, and we're not going to tell them what the spec is for opening our file, but hopefully they'll be able to figure out if they get enough samples from their friends, and then maybe they can open it, maybe all the data is still there. We just kind of want to step over that and challenge the industry's notion of doing that with something like, let's just send things in CSVs that have basic listings of stuff. Because if this is what, this chick can do for free, then why are you charging me for something that also charges me more money down the line? Why are you charging me some money for something that is not serving my use case, not serving my needs, and maybe even violating some laws in the process? So demo. Let's see, can I demo off this? Yes. All right, moment of truth. Or can I demo off of, yeah, I can. Sweet. All right, so we'll take this right out of my IDE. This is going to be a debug build. If you saw any previews on YouTube or something, this is a new set. So we can go in here. This is the basic UI. The most important feature is that we have a dark mode. That's can't be without that. We can change the text size, which is very good for things that are hard to use. I'm going to keep it about this size right now so you can see everything that's in the table over on the right. But the basics of it is that we can choose a folder and we can say, yes, I want to do this one. We inventory it. And also notice that there's an innovation here, or at least kind of a pattern I like to work with these programs where I do like documentation as UI or like GUI as docs, where there is no separate manual. There is no $250,000, $500,000 training on the other side of the world that you have to send all of your people to learn how to use this. It just happens to be like a listed document. As we add more features, this list on the left gets longer. And once we get to the end, there will be no more features because we have the ability to say no. We are not desperate for customers. We're not desperate to make the next sale or to make the stock price go up or something. We just want to make software and give it to the people who need it. Now, whenever we inventory the file, we have the path of each file. We have an MD5 hash or a SHA-1, SHA-256. We have the file existence and the file integrity. Right now, these are unaudited. So we can go through and say that I just got this set of files, and inside of it, I see that there's already an existing CSV. Now, that was just created whenever we did the inventory step there. Now we can go in and find one of those CSVs. Let's say this one from earlier. Each CSV is timestamped, which makes our automatic chain of custody. Excuse me. We can audit that. Go. Let's see. Yep, exists in manifest. And the file integrity is good. It matches, which means that everything that was there before is still there now. That CSV can travel along with the files and the folders, and even better, because Rust is so awesome, this executable is so small, it has 0 dependencies, it can even travel with the data as it goes. Now, there are a lot of issues about zipping up an executable and putting it into an email. A lot of things really don't like that. Google Drive doesn't like it. But the fact that you can do it is cool. And I think it's really interesting that we can keep the data coupled with the application that's used to process it, and the application can move with the data instead of being in a place where the application is the server-side thing, which needs to have logins, and maybe if there's like a guest organization you need to bring on, and then they need to come in and make an email, and then they need to, across certain boundaries is just not available. This just runs locally and works everywhere as it is. And this is just the beginning, as we'll kind of get into later. Let's head back to the presentation. So, surprising advantage of localisms. Whenever I first started this, I'd always been server-side, and honestly, Rust, I like to say, is my first big boy language. It was the first time I had done something that was like statically typed and compiled in a reasonable way. And also kind of backtracking through the past 10 or 20 years of trying to rediscover shipping to desktops. How do icons work? How does signing notarization work? What are all these different types of MSIs and EXEs, and why is Microsoft trying to get rid of the EXE? Like, what's going on there? And what I was surprised is that it's really simple. Client-side binary means that everything is very stateful. What you see in the UI there is what you get. You're looking directly into the database. We live in this world now where we have a lot of like state sync issues, where every time you click something on a website, there's a little voice inside of your head that isn't really sure if you're looking at the current version of the data. And maybe if you refresh it, it'll log you out, or maybe it'll change something. Maybe there's like a little green submit button hanging out at the bottom. Whereas for this, with Folsum and the other applications in TFT's constellation of counter-human trafficking and forensic software, we always show you exactly what's happening right now. So there's a lot of fun little things there with like mutacies and concurrency and channels, and that's a whole different talk where we're always updating it and constantly redrawing the GUI to show you exactly what's happening. Which also means from a UX point of view, there is no loading bar. There is no little spinner. There's no little hamster wheel like rainbow wheel that comes up and lets you know the application is still alive because the number of files is going up. The table is changing. It's very obvious what's happening, and it's very obvious whenever it's done. I think it needs a bit more color, but we got the dark theme, so it's okay for now. Portability, we can ship EXE as long as it isn't marked as malware. And we get away from the React update paradigm too with the UI. We're using Ernerfeldt's eGUI, which is absolutely lovely. We went through like 4 or 5 different GUIs before that. And eGUI is the one that's just very simple, very easy to use. And I don't know, maybe it's my own traumas. I'm dealing with Kubernetes-based applications with, sharded Next.js and like the RESTful API. And whenever you do that, you get to have 2 interfaces where there's a RESTful API and then there's the front end. And every time you update something, you have 2 or 3 interfaces to go through, not to mention like the database interface. This gets it down to actually 1. And it's very informative whenever something isn't working because the whole thing crashes, which is great because it fails informatively. Something's busted. And if that happens to a user, that means they're actually going to send you the log file. At the end of the day, this also means that we have Guerrilla scaling. Usually whenever we think scaling, like, you hear this all the time in Silicon Valley, scale, scale, scale. We should be able to go from 1 micro EC2 up to 1 million medium EC2s for the day that someone clicks on your application. It gets shared by an awesome YouTuber here at the conference or something. And then, 500,000 people come in and click on it. But we also have, thin clients. We have these fun little things. And if you get 100 people all using the same application working on one case, that's scaling too. It's meat-space scaling. Usually in these enterprise environments, we have NFS shares, so they have shared data. Hopefully they don't run this against those shares, because I think that'll overwhelm the drive pretty quickly. Oops. But they have that, and they have email. So that becomes our networking, and that becomes our storage layer. We don't have to deal with any of that, which is kind of wild. This is kind of like a virus for good, I like to think about it, or like a retrovirus for society. This is public infrastructure, maybe even critical infrastructure, if I can go so far to say that. And it's a benefit of being human. It's not really specific to any one country. It's not something that needs to be maintained or constantly updated, because it's Rust, it's pretty solid. And honestly, whenever you write something for government, it might take a while to get it into a government space, but once it's there, there's a good chance that it will outlive you, whether you like it or not. So why Rust? Not because it's fast, but because it can go faster. There's no performance ceiling. There are quite a few sins that I commit in the code base just to get things working. Especially a lot of the nicer language features that I catch myself trying to put in, like maps, flat maps. I'll nest for loops. I'll do some really dirty things, and for the most part, the compiler takes care of me and makes it all go away. I do keep a benchmark, or I guess 2 or 3 benchmarks, and quite a few unit tests, so I can watch what kind of debt I'm taking on. But I'm very skeptical about getting too clever with my code, or making something that's too well implemented, something that looks too pretty. But if it compiles, it works. There's no DOA ships. As soon as I go in, as soon as I run, I can change something. I can run cargo check, especially if I can cargo test and run my integration test. By that point, I'm feeling pretty good already. And as a solo dev, I can ship that and be pretty confident that if they go through another 3-week procurement cycle to get 4 or 5 people to sign up on it, and get the new signature added to the whitelist and with the vendors and everything, they bring it in, I'm not going to get an email the next day that something crashes or says something is gone until you do, and then it's scary, but we don't talk about that. Rust features in action. It's a functional language, and forensics is honestly very functional. A lot of this is emulating what people do, or what digital forensic examiners do with command line tools. But command line tools assumes that you know how to open terminal and use it, and that you know what those tools do in the first place. That is a combination of both scripting knowledge and subject matter expert that is becoming more and more rare, especially as everything is understaffed. And every time you call into something now, it's record number of calls, and there are fewer and fewer people to do this work, so we have to make the most of the people's time that we can. So either we need to democratize it and move it over so people who aren't SMEs can do more of that work, or so people who are SMEs can do more with the time that they have. One of my favorite things is that whenever I add something to a forensics program, generally it's not adding a new function, but adding a new field to a struct. And if you have 2 of these structs that run all the way through, say, 10 or 15,000 lines of Rust code in some of our more advanced offerings, that can be really scary in other languages. And even if it passes, even if it compiles, you don't really know, we can't really trust if that's actually going to be okay. But in Rust it is. I can go through and do Command R, I can change the name of something, I can add a new field, I can add a new implementation, and if the compiler says it's good, it actually is good. And I don't think that's something I could actually do in another language. And there's this whole era of developer ergonomics that I think is kind of left out of the conversation a lot of times, where it behaves almost like a higher order, more like abstraction-oriented languages without any object-oriented programming. There's a lot of stuff that's taken care of for you, and a lot of time-saving stuff that doesn't look cool or shiny at first, but it's really hard to represent problems that you don't have, or efficiencies that, how do you quantify all of the bad things that didn't happen here? Kind of think like an insurance company or something. Let's see. Oh, and opinionated simplicity too. Because it's opinionated, everything is simple. There's a right way to do things. There isn't a million different ways to do things like there is in C. I can link things together, I can build things consistently, and I've even doubled down on this idea of opinionation, where I'll implement things in a consistent way that doesn't really make sense for the particular use case, but because it is consistent whenever something breaks, whenever I get a log file back, in my head, I can think about how I would have implemented it and then make a fix. And usually whenever I go to the code where that happened, I'm right. So it's kind of nice. There's nice economies of scale. It's a solo dev that happened there. One of my users said that it's everything that it needs and it's nothing more, which I love because that's a big chunk of the design philosophy, which is just extreme reductionism. Before this was, I think our biggest update for this was actually making a WCAG compliant UI and UX things, so the contrast here is a bit easier to see. Every time I come down to, can I make this a better feature or can I ship easier, I go for the easier shipment. Everything from choosing UI library to adding new crates, new packages, it always comes down to, can I ship, will it compile, will it be easier to deal with in the future? Because most of this is actually just sticking with standard library as much as possible. More recently, for a previous talk, Linux Weekly News had a post about my talk, and one of the users had this really interesting point I like, where he brought up the idea that this isn't something that you can really do with a paid product. This isn't possible. Because something I point out is that, as you saw in the demo, it only has about 4 buttons, maybe 5 buttons. And I bring this to my users, and they're just astounded. They think this is great. And I'm sort of like, well, this was supposed to be like something very simple. I'm just trying to build a Corolla. You're saying this is like a Lambo. What's going on here? And he pointed out that whenever you go in and, see, this is a little bigger so the text isn't so small. Whenever you're trying to make a product, every new customer that you have to sell to wants a new button. And sometimes they want conditional buttons. And every time you move along, every time you add these new things, it makes the app more and more unwieldy. And as developers, we know that more features and more stuff in the code base gets exponentially more difficult to maintain, and it makes it harder to add more features in the future. So what this really comes down to is the ability to say no. I can say no to people. I can say that that's not going to be good, and once that page fills up on the left side, then that'll be, that'll just be going into maintenance mode after that. No views, no panels, no secondary things. It just is what it is. Kind of inspired by like the old sketchy executables used to download for like a video game to change the INI files. You go into SourceForge and you download this little gray box thing. It has FLTK front end, and you're like, this might give me malware. It's gonna make me play my game, and I think I'm cool with that. That's sort of the inspiration here, but good malware. Pirates for good. Inside of Rust, I really love that we have our batteries included. I've stayed away from async code, even Tokyo. It's all just standard library pieces. Very few advanced language features, like I said, flat map, anything cool like that. Staying away from those things mostly because I've put them in 2 or 3 times, and I find that I have to take them out in the next 2 or 3 weeks later because something changes, or I need to diagnose something, I need an extra debug statement somewhere. And yeah, I think this will change in the future. I'm preparing for a future where right now I think my average user generally summarizes a directory with about 450, maybe 600 files in it. Some of them are 3 or 4 gigs a piece, up to maybe 20 or 30 if there's a few video files in there. But once we started getting over to digital examiners, they're perfectly fine with running this on a 4 or 5 terabyte image of a drive, and they want it to unpack everything or recursively go into directories. And there's a whole other set of users there that you unlock once you start getting Steam in this space. And that's whenever Rust's high performance ceiling is really going to kick in. So I'm finally going to get a ticket whenever I'm going to have a user say it needs to go faster. I'm going to jump up and down, and I'm just going to laugh and scream, because that's whenever I'm finally going to give myself permission to go through and optimize things. Although I'm kind of have this nightmare where I go through and optimize it, and it doesn't get any faster because the compiler is just smarter than me the whole time. Let's hope that isn't the case. I also have lots of comments and docstrings everywhere. Whenever I get back a log file, by the time I go in and I need to look up what happened, I generally want to be able to just with Vim, Shift G, line number, go to that direct line and instantly know what's going on without scrolling up or scrolling down. I tend to say why I do things, where I do things. And with Rust, there's already a really strong standard for how we document things, how you can document, even the public functions for major modules and things. And that's awesome that there's a right way to do that. Coming from Python, where I had 4 or 5 different ways that I could document, the types or arguments in a function or something like that. This is much simpler because there's a right way to do it, even in the documentation. Deploying to all the things. This is where it got really interesting. This is honestly 80% of the time that I've put into Folsum and TFT's other things was just figuring out how to ship. And part of that was because Folsum was a younger language, so you don't have like this wealth of information out there for how to build for these different platforms and binaries, but also because a lot of this is kind of a lost art. It isn't really like shared anymore. On one hand, I could have gone with C++, but then you'd like have a C++ redistributor license. For the UI, it could have been a bit more interesting. I could have had like a Qt or something like that, but that would have been a dependency. Could have gone with Java. A lot of people say like, why don't you do like a Java program? And I'm like, I don't think the JVM is on the machine, and if it is, it's way older than like you want it to be. I don't know what kind of features or what version that's even going to be in the first place. I was also very picky about keeping this efficient. And efficient for me means I should be able to build it all on my laptop. So no Windows runners. This can all be built right here and shipped directly outward. I did some time experimenting with GitHub Actions, especially with macOS runners and some things for making, automatically making MSI installers with Windows. But if you look carefully enough, there are ways around all of these things. You can do it all on one machine without having like VMs or using Wine or something like that. Let's see, as we go into desktop development items, it's not lost, it's just kind of retro. This is what I try to tell people in SF, and they don't quite believe me, but they're starting to. Whenever we deploy to desktop, it's a pre.com skill set, as I said, and going through and figuring these things out is kind of a ride, especially whenever we come down to this tension between like the next wave containers, as I call them, where exe used to be the thing. We love exes because you can click on it even from a USB, and click on it from an email. It'll happily give a virus to you. But now we're kind of moving over to MSIs, where Windows is very keen on everything having an installer and having an installer set and wants the installer to be signed and this and that. So the docs aren't super strong, and even if you're looking at code signing and so on, that's generally not like a first-class citizen anymore. In the macOS ecosystem, there's a similar thing where if you want to ship something with a library or package, if you want to include a framework for any advanced features, you don't want to do a package like a .pkg, but then they also want you to be pushing through app stores. There's also a lot of .app support. But you'll notice that sometimes, say for a DaVinci Resolve video editor, the vision of the .app that you get off the App Store whenever you're just trying things out has a slightly different feature set than we do with the .pkg and a slightly different way that it's serviced. Whenever you upgrade, in that case, from the .app to the .pkg, there are different places on the OS where you can store those files, so your persistence doesn't carry over, and you get a lot of issues there. So it's hard to tell, like, okay, like OS manufacturer, what is your container of the week, and where are you documenting this? Some of these things, I think one notable thing was finding the right icon sizes and right icon formats for .apps. Ended up going down to like an Apple developer conference release from like 5 or 6 years ago, which finally talked about like, how do I do this? What format? What size should it be in? Like I said, 8% of the time sync was just shipping in things. How am I doing? I haven't been watching the time at all. Okay, cool. So going in, like figuring out the shipping stuff, I think Go Releaser is really awesome. And whenever I was working through these issues, I was like, wow, Go really has this figured out. Maybe I should just go and rewrite everything in Go. I'm glad that I didn't, and I stuck with Rust, because at the end of the day, I'd rather suffer with the language than I know than have an easy time with the language that I don't. I think we have Tori a lot to thank you for some of their foundational work. Looking at their code base really gave me an idea of like figuring out for how do you think about this and how can you do this all in parallel? How can you get this all working? Yeah, so we went through MSI to replacing the exe, PKG, and app. Then we get to code signing. I just dished out $1,500 to DigiCert for an extended validation cert a couple of weeks ago, just so it isn't marked as malware anymore, because at one point that happened. Up until that point, with enterprise environments, you can have them whitelisted with their vendor, and let's see, with their security vendor, with their scanning vendor, and with their own system for every release, every deployment. Each one's like a 20 or 30 email chain. Eventually, one of the things doesn't happen. It gets onto a Windows build. There's this little executable floating around. Windows finds it, and it has a notification that pops up that says, hey, we found malware on your computer, and we deleted it. And then the email that you get from your user is that the thing is gone. You're like, it can't be gone, but no, it's really gone. The OS deleted it. Meanwhile, good old macOS and Apple charges only $100 a year for their Apple ID cert. That doesn't give you extended validation, and instead of Trafficking Free Tomorrow being the organization that pops up, it's just Brooke Doosan. So they're like, who's this chick? But it's better than nothing, and it's a lot less than $1,500. So I'm kind of looking at that now like, App Store, 30% reduction. That's kind of a big thing right now. But on the other hand, they decompile the code and they actually do things, whereas DigiCert's just kind of signing off and saying, it's cool, with a big price tag. I don't think that's awesome. For testing, there's about 1 unit test per module on average. Some have 4 or 5, and I definitely test the public function. That's like the big thing that I always go through and do. Next test makes us all magically faster for free. I absolutely love it. And that dovetails very nicely with benchmarking. I don't look at these charts a ton, I'll be honest, but I do glance at them every now and then, especially whenever I do a big change or a big piece. And because I save every benchmark's results, I can see benchmarks and how they change over time. And then I can look over here at the flame graph and be like, okay, where did I mess up? So as long as nothing is getting like too awful, as long as I'm not getting these massive performance spikes, it's okay. And eventually, like I said, I think once we move to channels especially, we'll be able to go through and actually optimize this area and make it go just wicked fast, right? User reception. Like I said, I was trying to build a Corolla and they say it's a Lambo. It turns out this is actually really cool. This is an underserved market where people are used to having really terrible software that either doesn't exist, is very expensive, and it's just bad all around. So they see something like this that's simple, that's shippable, and actually meets the things that they're asking for. It's particularly cool, and I don't think there's any other way to really make this. It's very difficult to charge for this kind of thing. It's difficult to work through procurement processes. It's difficult to work the internationalization, crossing borders. There's always crazy policies and like council votes you have to go through a lot of times, and making it free, making a nonprofit skips a lot of that bureaucracy and makes this possible. In the future, moving from indices to channels, I have an early version of Folsum especially where I get a 250% increase in performance, which is pretty cool. Using Crossbeam for this is a good time, and I don't know why we don't talk more about how awesome channels are. Like I'm kind of like spreading the word, like have you heard of channels? And coming from Python, especially from a soft science background, I don't have any formal training in any of this, so maybe it's something that comes up in CS degrees, but I'm like, channels, and they're like, we know. But I think it's just awesome. Maybe at some point async. I don't know where that's going to go. I like to keep it contained to one place, but this touches disks a ton, as you saw, and especially for some of the larger files, because there's so much I/O happening there. There's got to be some async optimizations that we can do here. I love ripgrep. I love doing RG for just everything. I think I use that 5 or 6 times today for everything from last minute slide edits to checking my email, and it's just an awesome code base. And I've glanced at it before, and they have a really clever way of traversing directories that I'd like to work into this somehow. Maybe adding a progress bar that actually means something without being like, though it's moving along, each tick should actually represent like a byte that's happening or something. You can actually see that. And I guess in the future, the bigger vision for this is that this would be one of a constellation of many items. Instead of having one giant monolithic application that costs $500,000, we have lots of smaller ones, kind of like Linux utilities. Different areas, different countries, different people with different needs, different agencies can take the pieces that they want, and because they're all interoperable, they can use all of them or none of them as they need. And we can challenge this idea of a panacea platform. So whenever this salesman walks into one of your representative's offices and says, we'll take all of your data, we'll do all of it, just send it over to the United States and we'll handle it for you, we can challenge that idea because there are other alternative ways of doing this. This is utility for being human. We want to challenge industry assumptions, as I said. We want to have free tools. We want to respect the investigator and the victim. And I think this is the way to do it. Special thanks to Mayor Boss and Luke Palmieri's work. That was really helpful. I love these books for actually teaching me how to do concurrency and how to write efficient code. Well, Palmieri's book was more cloud-focused for a lot of the stuff. It was my first introduction to like what a mature delivery pipeline looks like, and especially to kind of, give me the confidence that if I put the work into automating these things, then it'll actually pay off in the future, which it has, because everything that I go through to change things, there's a slide a little bit further back where we were talking about, let's see, Xtask. I think I have like 20 or 30 Xtask commands now. Even that screenshot was a bit old. And commands will call other commands, and having that all automated and having that repeatable is awesome for time savings. And yeah, I think for now we can move into the Q&A.
Right. Thank you very much.